How's it going, everyone? This video is going to show how to calculate the standard deviation of a set of values. Now, whenever there's a standard deviation question, you want to pay attention to whether it's asking for the sample standard deviation or the population standard deviation, because the calculations are a little bit different. So for example, if we take the first question right here, well, let's call that A. It says find the standard deviation of the following values taken from a sample. So there's the key word there, sample. That tells you it's the sample standard deviation. If we look at the bottom problem, let's call it B, find the population standard deviation of the following values. Well, there's that keyword population standard deviation, which means it's the population standard deviation that you're looking for. Now, the steps to calculate these standard deviations are very similar. It's just at the very end there's a slight difference. So the formula for standard deviation is as follows. It's the sum of the squared differences between the data points and the mean value. And if it's the sample standard deviation, you're dividing by n minus 1, where n is your sample size. And the sample standard deviation is typically represented with the lowercase English s. For population standard deviation, it's typically represented with sigma, which is the lowercase Greek s. And you're also adding up all of the squared differences between the data points and their mean value. But instead of dividing by n minus 1, you're dividing by n, which is the sample size. And that's the only difference between the two formulas. So I'll go through question A here, calculating the sample standard deviation, and then I'll show you the one thing that's different if you're looking for the population standard deviation, as in question B. Now, the first thing you need if you're calculating the standard deviation is you need the mean value, okay, because you're looking for the difference between the data points and the mean value, okay? So that's step one, is find the mean value of your data points, okay? So we'll call this part A, right? Question A. So step one is find the mean value, okay? So the sample mean is going to be the sum of all of the data points. It's actually the same data points for both questions. It's the sum of all of the data points divided by the sample size, or the number of data points. So in this case we have 6 data points, so we will be dividing by 6. Okay, so here this makes a 10, and then this makes a 3, combined with this 3 is a 6. Another 6, that's a 12 plus 10, 22 divided by 6. 22 divided by 6 is 3.67. I'm rounding to 2 decimal places here. If you round to a different number of decimal places, your answer will be slightly different. So that's step one. Now that we have our sample mean, well, then we want to calculate the difference between each data point and the sample mean, and then we want to square those differences, and that is most easily done with a table. So this is step 2. Create a table where one column is your data points. The next column is the difference between your data points and the mean value. And the last column is those differences squared. So our data points are 1, 2, 6, 4, 6, 3. And we know this is our mean value, 3.67. So we're going to subtract 3.67 from each of the data points. So 4 minus 3.67, again 6 minus 3.67, and 3 minus 3.67. And we're going to write down the answer to each of those. So 1 minus 3.67 is negative 2.67. Okay, this is going to be negative 1.67. 6 minus 3.67 is 2.33. 4 minus 3.67 is 0.33. And this is a 2.33 again, and this is going to be negative 0.67. Now the final column is going to take all of those differences and square them. So we're going to have negative 2.67 squared. We're going to have negative 1.67 squared, and so on. 2.33 squared, 0.33 squared, 2.33 squared again, and negative 0.67 squared. So we'll calculate all of those. Now, of course, when you're squaring something, it doesn't matter if it's negative or positive. The answer will be positive either way. So here you could do 2.67 squared or negative 2.67 squared. The answer will be the same. And that is 7.13. Negative 1.67 squared is 2.79. 2.33 squared is 5.43. 0.33 squared is 0.11. And this is 5.43 again. We already had 2.33 squared. And then the last one, negative 0.67 squared, and that gives you 0.45. So now that we have all of our squared differences, the next step is to add them all up. That's the next step in the formula. Add up all of those squared differences. So we just add them all up. And that's going to be the sum of that last column here. Okay? Adding all of those up. So we have 7.13 plus 2.79 plus 5.43 plus 0.11 plus 5.43 again, and then plus 0.45. And that gives us 21.34. That's the sum. So the only thing we have left to do with that sum is divide it by n minus 1 and then take the square root of the result. And that's it. We divide it by n minus 1 and take the square root of the result. Well, so the sample standard deviation will be 21.34 divided by n minus 1, and we take the square root. N minus 1 is 5, right? Because we have 6 data points, so one less than that is 5. 21.34 divided by 5 is 4.268. And when we take the square root of that, we get 2.066. Okay? And that's our answer for the sample standard deviation, 2.066. Now, That's part A. Okay? If we were doing part B, the only thing that's different is our very last step. We divide by n before taking the square root, rather than dividing by n minus 1. Everything else is the same. You calculate your mean value, you take the difference, right? You create that table where you look at the difference between your data point and the mean value. You square those differences. You add up all of those squared differences. That's all the same. Then you divide by n instead of dividing by n minus 1. And after dividing by n, you take the square root. So step 1 would be the same. Step 2 would be the same. Technically, you would be using the mu symbol instead of the x bar symbol, because that's the symbol for population mean rather than sample mean, but the calculation is exactly the same. The only difference is that step where you divide by n instead of dividing by n minus 1. So for part B, after we have our sum, which is the same sum, 21.34, we're going to take 21.34 and divide by n and take the square root. And that's going to be our population standard deviation. So you'll have 21.34 divided by 6, because 6 is our sample size. We're not subtracting 1 from it. 21.34 divided by 6 is 3.557. And when we take the square root of that, we get 1.886. And that's our answer for the population standard deviation, 1.886. So that's how you calculate the sample standard deviation and the population standard deviation. Step 1 is the same, find the mean value. Step 2 is the same, create that table where you subtract the mean value from every data point, and whatever the difference is, you're going to square all those differences in your last column, then you're going to add up all those differences. If you're looking for the sample standard deviation, you take that sum, divide it by n minus 1, and take the square root of the result. And if you're looking for the population standard deviation, you're going to divide by n, and then take the square root of the result, where n is your sample size in both cases. So I hope that helps, and until next time.